Welcome to Mr. Wilczewski's lectures on chemical bonds. This is section 6, metallic bonding. All right, so here's a drawing that represents a metallic bond. So these spheres represent metal ions, well, let's say metal atoms. So imagine it's a sodium atom. It has an electron. And the electron in metals can be shared by more than one atom. So imagine this electron here on this sodium atom, remember sodium has one electron in its outer shell, gets lost and starts revolving around between all these different atoms. Now, I don't like the word shared because it makes you think it's a covalent bond. So you have all these electrons moving around from all of these atoms. So this sodium loses an electron, becomes a positive ion. This one becomes positive. They all become positive ions because those electrons start migrating between all the atoms. And it's kind of hard to see, but there's this light blue cube that represents the electron cloud, that's what we call it. So there's a cloud of electrons, or an electron sea. So a metallic bond is described as positive ions in an electron sea. Okay. Now, this is different than what we've seen before in ionic or molecular compounds. So, and this type of bonding gives way to some of the characteristic properties of metals, such as electrical conductivity. Well, you got all those free moving electrons, and that's what electricity is, the moving electron. That's why metals conduct electricities. They are also thermal conductivity, malleability. You have all these positive ions surrounded by the negative electron sea, and you shift them a little bit, like you try to bend or mold a piece of metal, those positive ions can shift, and you still have the same arrangement. You still have positive ions in an electron sea. You try to do that with an ionic compound where you've got positive and negative things next to each other, then you shift it a little bit, and all of a sudden you got positive next to each other. That's not comfortable, and negative next to each other. That's not comfortable. That's why crystals will fracture when you put some pressure on them. But metals, especially when heated, you can mold them, and they're malleable. You can hit them with a hammer and shape them. They're also ductile. That means you can draw them into wire. Try doing that with a piece of salt. Okay. All right, they're shining in appearance because you've got all these electrons absorbing and releasing energy. All right, so what is malleability? Well, it's the ability of a substance to be hammered, or mallet's another name for hammer, or beaten into thin sheets. And ductility is the ability of a substance to be drawn, pulled, or extruded into small openings. And in other words, you can make wire out of it. All right, so here's some drawings. We have an artist rendering of metallic bonds. You've got these positive green ions here surrounded by the sea of electrons. In an ionic bond, you've got a positive ion and a negative ion, and they're attracted by that positive negative attractive force. And a covalent substance, you've got the two atoms and you're sharing electrons in between it. All right, and this bonding explains the different properties of these substances. You've got metals, which conduct electricity. They're easily shaped, ductile, and so forth. The ionic compounds, they're crystalline. They make these cool geometric crystals of positive and negative ions, but they're easily split. They're very brittle. They're hard, but they're very brittle. And the covalent compounds, which form molecules, because you've got a fixed number of atoms sharing electrons in a, quote, molecule. All right. So in a metal, those valence orbitals, they're all in the outer shell. They overlap. And the overlapping allows the outer electrons to move freely throughout the metal. And we have a special name for this. We call these delocalized electrons, which means they do not belong to any one atom, but they move freely about the metal's network of empty atomic orbitals. Okay. The term we like here is a sea of electrons. These mobile electrons form a sea of electrons around the metal atoms, which are packed tightly in a crystal lattice. So electron sea is the name for the mobile electrons surrounding the positive ions in metallic bonds. Okay, so a definition: the chemical bonding that results from the attraction between metal ions and the surrounding sea of electrons. That's our metallic bond. All right, now let's talk a little bit about alloys. Alloys is another name for a solution of like one metal dissolved in another metal. Right? For example, pure gold has just gold atoms in it, but 14 karat gold is an alloy of gold with silver and copper. And 14 karat gold is 14/24 or 58.3% gold. That's how we get the 14 karat uh, measurement from. Okay, so that concludes the end of this power lecture. If you want to do more practice, if you have access, you should have access to the PowerPoint, then you can do more practice on a number of different things that we worked on in this lesson. Okay, so that concludes our lessons on chemical bonds.